My dear students, welcome to APG Pathshala. I am Dr. P. Suganya, belongs to the Department of Food Processing and Preservation Technology, Avinashlingam University. In continuation with classification and selection of dryers, today we will be seeing about sun and solar drying, cabinet and bed drying. The early civilization developed in the warmer and sunnier areas of the world, and sun drying was an obvious choice as a method of preserving foodstuffs. It is worth recalling that sun drying is nature's way of preserving grains produced by plants during the growing season. Let us see about the objectives of this lesson. To explain about sun, solar, tray and different types of bed dryers used in food processing, and to interpret food processing applications in these dryers. The agricultural product drying method can be broadly classified into two: sun or solar drying, artificial drying with mechanical means. Let us see about sun drying. As we all know that sun drying is an age-old method of drying for crop, grains, fruits, vegetables, fish, etc. In India, major portion of crops is left in the field and threshing yard for drying under sun. Grains are dried on the plant till proper moisture content is attained. This drying method is slow and takes about 2 to 3 weeks to attain proper moisture content. There is an improved method of drying where crop is harvested at high moisture content and is left in the field or on bunds of the field till it has dried to proper moisture content. The another improved method is to dry the harvested crops on the racks. The crop is bundled near the ears and hung on the rope exposed to the sun. In further improved method of sun drying, the harvested crop at high moisture content is threshed and the grains are spread on the floor as a thin layer. It is continuously stirred manually till it has attained the storage and processing moisture content. Now, let us see about pros and cons of sun drying. The sun radiation is in electromagnetic waves and are associated with the following features: uncontrolled and non-uniform drying of grains results in cracks, which further leads to less head rise yield during milling process. The drying process completely depends on the solar energy and hence this method will not suitable for all seasons. Highly impossible to control the process. This method of drying requires huge number of labors. Contamination from the environment and grain loss will be 1 to 2% due to birds, insects and rodent attack. For sun drying, no fuel or other energy sources required, hence the cost of operation is low when comparing to the other artificial drying methods. The space requirement is high. So, however, sun drying is the cheapest method for food drying. In recent years, the drying method is replaced by solar and other mechanical type of dryers. In-store drying. In-store drying can also be called low temperature in bin drying. It may be used when grains are stored until milled. Weather conditions in tropical climates are less favorable for in-store drying due to high ambient temperatures and relative humidity. 2 stages drying can be produced good quality grains and preventing discoloration of high moisture grains and reduced cracking in the kernel. Solar drying. Solar drying is an extension of sun drying. It can be a means of supplementing or replacing artificial dryers with consequential savings in fuels and cost. Solar drying provides higher air temperature and lower relative humidity than simple sun drying. It enhances the drying rate and lower final moisture content of dried products. As a result, the risk of spoilage is reduced in drying as well as in storage of dried grains. In many instances, solar dryer is the best alternative method for drying foods. Though, in some type of solar drying system requires a power source, considerable savings in energy cost is possible. The 2 basic principles are inherent in the operation of solar dryers. One, the solar heating of air. Second one, the removal of moisture from wet material by heated air. In recent years, solar drying method is used widely in food processing sector. Solar drying is the most economic method when comparing to other mechanical dryers. Let's see in detail about solar dryer. Solar dryers consist of three important components: solar collector, drying chamber and airflow systems. Solar collector heats the air and then passes to the drying chamber. In the drying chamber, trays are arranged to keep the food materials, and sometimes the drying chamber is insulated to increase the efficiency of the drying process. Natural convection or forced air convection system is followed. In forced convection method, blowers are used to circulate the air to enhance the drying process. Solar collector, which is called as absorber, is a dark colored box made up of radiant energy transmitting material made of glass or fiberglass and energy absorbing material such as metal also. The radiation falls on the surface of the transparent cover, and dark color promote the absorption of solar radiation into the absorbing plate. The air gets heated when passing through the plate, then hot air is used as a source to dry the materials inside the drying chamber. Now, let's see about the classification of solar dryers. The first classification is direct dryers with natural convection and with combined collector and drying chamber. The solar collector is made by spreading burnt rice husk on level ground. It is covered with plastic sheet on an inclined bamboo framework. The drying chamber is a shallow wooden base with either perforated metal or bamboo matting. The drying chamber has removable panels at the back. It is provided with a chimney to provide a column of warm air for increasing the draught or the flow of air. The dryer is successfully used to dry paddy in monsoon. The second classification is direct dryer with natural convection and with separate collector and drying chamber. The most popular variation of this type of dryer is solar cabinet dryer. This consists of an rectangular cabinet, preferably insulated and covered with roof or glass or clear plastic. The holes are made through the base and upper part of the cabinet. The perforated drying trays are positioned within the cabinet. The insulation passes through the roof and is absorbed on the black and interior surface, which are then heated and warm the air within the cabinet. The warmed air rises by natural convection and passes out of the upper holes. In the meantime, the fresh air enters through the base holes. The length of the cabinet should be 3 times the width to minimize the shading effect of the sides. The angle of the roofs should be such as to maximize the amount of insulation received. The third type of solar dryer is indirect dryer with forced convection and with separate collector and drying chamber. In this type, the roof of the dryer is commonly used as solar collector. The warm air from the roof section is sucked by a blower and delivered to the lower plenum chamber under the drying bin. The warm air is ventilated through the products kept in the drying racks or chamber, and it leaves the room through north facing roof. Now coming to the applications of solar dryer. The solar dryer is mostly applicable in agricultural crops and dehydration of fruits and vegetable products. The specific products like mango, banana, apple, tomato, chili, etc. the solar dryer is highly suitable. Now let's see about the mechanical dryers. To overcome the disadvantages in natural and solar dryers, the mechanical dryers are introduced where it is possible to fix perforated temperature with minimum contamination. The tray dryer, tunnel dryer, conveyor type of dryers and bed dryers are discussed in this chapter. Tray dryer. The tray dryer are used in domestic and industrial applications due to its simple and economic design. The tray dryers consist of a stack of trays arranged inside the insulated chamber where the hot air is circulated. The trays may be or may not be have perforated bottom. The perforated trays are used when the plenum chamber is at the bottom of the drying chamber. The heater is provided to heat the air stream, and blower increases the preferable velocity of the air. If the heated air is coming from the sides of the drying chamber, the tray may not have perforated bottom. The gap between the group of trays permits air ventilation. The vent is provided at the top of the dryer to release the moist air. Uniform distribution of airflow over the trays is maintained in the tray dryers. The tray dryers are generally used for drying of vegetables and similar type of semi-perishables, and the product are kept in thin layers in the trays. In tray dryer, the drying time varies from 10 to 60 hours. Bin type dryers are sometimes used for the final drying and equilibrium of some dried vegetables. Although often with large modern conveyor dryers, they are no longer needed. They are essentially large vertical cylindrical bins with perforated bottom through which constant stream of warm air is blown. The next type of dryer is a tunnel dryer. This is similar to the tray dryer. When the group of trays are stationary, that system is called a tray dryer, but when a group of trays are moving in a tunnel, that system becomes a tunnel dryer. The flow of heated air in a tunnel dryer may be co-current or countercurrent. Tunnel dryer is a direct continuous type and large scale type of dryer. In tunnel dryer, the food materials to be dried are kept in the air heater tunnel. The material is entered at one end and dried material are collected at exit end of the tunnel dryer. Tunnel dryers possesses all advantages of tray dryers. In addition, they have a semi-continuous operation. This type of dryer is very popular for drying vegetables and fruits. As compared to the tray dryer, the investment costs are higher. The wet materials are loaded in trays that are stacked on trolleys. The trolleys are introduced periodically into one end of the tunnel and removed at the other end. A typical tunnel dryer can be operated in co-current or countercurrent flow of air and trolleys. Two-stage dryers are also used, featuring a short co-current stage followed by longer countercurrent stage. In cross-flow designs, the drying air moves at right angle to the path of the trays of foods. The basic modeling principle for this type of dryers are similar to that of a cabinet dryer. The drying times are similar to those in cabinet tray drying, while the airflow rate is linked to the total number of trays. The dimensions of the tunnel are calculated based on the necessary drying throughput, necessary drying time, and the dimensions and capacity of a single trolley. Now let's see about the conveyor type of dryers. Fully continuous drying operation is achieved in conveyor belt or band dryer. This type of dryer is also very popular in vegetable processing industry. The wet product formed or placed in a bed of different thickness is carried through a tunnel or perforated, that is a mesh slotted or lowered conveyors. The heated air is directed up or down through the conveyors and the layer of the product, usually up in the early drying stages and down towards the drying product exit, or directed across the material surface for the product in thin layers on non-perforated band. Some models consist of 2 or more conveyors in a series. Also, either co-current or counter-current configurations can be used. Such dryers are limited to foods that form a porous bed, that is cut, granulated, naturally particulate foods. For vegetable drying, multiple conveyor dryers, that is up to 5, one above the other, can be used. The wet product is introduced onto the top conveyor and progress downwards from one conveyor to the next. The air circulation is usually a combination of cross flow and through flow. A final drying step for some vegetables is provided often in this type of dryer. Gradually, the conveyor dryers are replacing drying trays in tunnels for vegetable pieces such as carrot, onion, and potato. Infrared, microwave, or radio frequency energy is sometimes additionally supplied to the product conveyed through the dryer. The drying unit may operate under vacuum or atmospheric conditions also. Now, let us see in brief about bed dryers. The first one is a deep bed dryer. Deep bed drying is generally practiced for on-form drying of grains. In this system of drying, all grains in the dryer are not exposed to the same conditions of drying. The grains are placed on the false perforated floor that is raised to a certain height above the ground. The space below this floor acts as an air plenum chamber. The natural air or hot air blown through the bed above it. The air flow through the grain mass in the bed carries the moisture. The moisture transfer from the grain to the outgoing air takes place in a finer depth or zone, which is also termed as drying front. This drying front moves upward in the bed in the direction of air movement. To avoid mold growth at the upper layer of the bed, this drying front should move quickly. Considering the large pressure drop and consequently the higher energy consumption for airflow across the bed, the volumetric airflow rates per unit volume of the grain is kept to the minimum level that would be just sufficient to prevent the spoilage of grains in the bed. The second one is the most important type of dryer is a fluidized bed dryer. The hot air at certain velocity is passed towards the upward direction through a bed of food material. The air stream expands and becomes agitated and suspended to form a fluidized bed. This is called fluidization. The more vigorous type of fluidization occurs at very high air velocities is called sprouting. The turbulence takes place in the bed makes very efficient contact between hot air stream and solid food particles and results in uniform mixing and high heat transfer rate. In this type of drying process, thermal efficiency is very high. The next one is a sprout bed dryer. The sprout bed dryer is a specific design of fluidized bed dryer, is also called as vortex bed dryers. Large size coarse solids can be handled in this type of dryers. Grain particle diameter of more than 5 mm is highly suitable for these type of dryers. A high velocity air allowed to enter through a centrally located nozzle in a conical base, a vertical chamber. The zone of fast moving particles at the center creates a sprout and the granular materials move downwards at the slower rate surrounding the central sprout. Thus, the downward moving grains generally receives the counter current moving air at the annular zone. The initial drying takes place at a higher rate in the central sprout, but the later drying in the annular bed is relatively mild. Next one is plug flow fluidized beds. If the length to width ratio of the fluidized bed is superior to above 4, it is no longer well mixed, but the solids flow continuously. A plug flow fluidized bed may be a simple straight channel 1 or 2 meters wide and up to 20 meters in length. The greater the length to width ratio is, the more uniform the residence time distribution. Next one is Vibro Fluid Bed. The Vibro Fluidized Bed are used to handle cohesive, sticky or fragile materials or those with a wide size distribution, especially oversized particles. In Vibro Fluidized Beds, the gas distribution is vibrated mechanically, allowing movement of the coarse or cohesive particles, while the gas velocity used for fluidization is low to avoid excessive separation of fine particles. With significantly lower upward velocity of air required compared to static fluidized beds, Vibro Fluidized Beds are interesting from the economical point of view. But the bed depth is lower, that is 0.3 meter, than in static beds about 1 meter, requiring large equipments. The next type of fluid bed is a pulsed fluid bed. The technique of drying of granular materials while keeping them in suspended state by continuous flow of air has been conventionally used widely in the drying of fruits and vegetables. In the pulsed fluid bed drying technique, the conventional fluid bed drying system is modified so that pulsation of the gas flow takes place, thereby causing high frequency vibrations within the bed of the product particles. This technique is reported to be effective in overcoming defluidization, particularly in the case of cohesive particles. Further, pulsation is expected to reduce channeling of particles and to affect easier fluidization of an irregular shaped particles. The requirement of saving energy is achieved by saving 30 to 50% of the air requirement for fluidization, because the air for fluidization in drying application consumes energy not only for its circulation but also for supply it at elevated temperature. Additionally, the dryers operating with pulsed fluid bed technique requires a smaller size. With the pulsed fluid bed drying, energy saving is achieved without affecting the production yield due to lower drying air requirement. The next one is a multi-stage fluidized bed. In many applications, 2 or more fluid beds with different functions are used in stages. For example, a well-mixed unit followed by a plug flow one allows wet and sticky materials to be handled. In some cases, the distributors is constructed so that both sections are part of the same bed. The last type of special dryer is a desiccated air dryer. The ambient air is passed through a desiccated medium or a source. The desiccator absorbs moisture from the air. As a result, the relative humidity of air is reduced, and at the same time there is an increase in its temperature. When such air comes in contact with the wet food materials, the transfer of moisture from food to drying air takes place. The drying action occurs due to convective heat transfer. Let's see the summary of this lesson. Nature sun drying is a traditional drying process used for crops and grains. Solar drying is advanced method of sun drying, which is energy economic method for drying applicable for almost all fruits and vegetables and grains. The mechanical drying methods such as tray dryer, tunnel dryer and bed dryers are advanced type of dryers which overcomes the limitations of natural drying methods. Different types of fluidized bed dryers are applicable for food materials. In this type of drying, uniform mixing of products and better heat and mass transfer rate takes place. In continuation of this module, we will be discussing about spray dryer, drum dryer, freeze dryer and other advanced type of dryers in the forthcoming lessons.